Y'all gonna say hi, right? Hi, Mariah, Colby.
Karen. Hey guys.
Everyone that's missing today.
They're hopeless, okay? They're hopeless. It's all right.
No, not at all.
So, however, as you be fast, I'm talking without you. As you are, I'm sure, aware by now, we do not have school on Friday, which means we are going to lose a white day. So consequently, I'm changing assignments around so that I keep you guys caught up with the other class. You'll notice up here I have on today's assignment, the October 28th assignment, you're taking these numbers off of it. On the first section, you're taking off number 5. On section 5.5, you're going to cross off 25, 29, 54, and 60. You're taking those away. Okay, from Wednesday's assignment, the assignment for the 30th, then you are going to add 3 problems. You're going to do, for today, you're going to add 21, 25, and 40. You're going to do those 3 as part of today's assignment. On Wednesday, I'm going to be gone. These 4 problems will, at the bottom will be your assignment on Wednesday, plus you'll be doing a worksheet in class with a partner. If you have more questions, ask your classmates. I'm sure they've got it straight. Okay, so meanwhile, though, we are headed off to how to solve quadratics by graphing. Okay. We know how to solve them by factoring now. We're aces at factoring.
Oh, yeah.
Okay. This first problem I have up here is one you could easily solve by factoring, but I want to solve it by factoring and then have you figure out what's that have to do with the graph. So if I was going to solve this one by factoring, what factors might you want to use? X and X, all right. Factors of 28. 7 and 4 would be good. And I need to make a -3 in the middle, so I would need it to be a -7 and a +4. Okay. And then what do I do with my factors? I set them equal to 0, thank you. And if I solve those, I will get x equals +7 and -4. Okay. Now, we're going to go graph that exact same equation. And I want you to remember 7 and -4 were the solutions. And I want you to tell me, what do 7 and -4 have to do with the graph? So we're going over here to a graph page, and we're going to type in, if you haven't hit tab, see you down there on the line, you're going to type in, you want x squared minus 3x minus 28. Okay. And if I hit enter, I'm going to get the expected parabola, okay, whose vertex is somewhere down a ways. Okay, and so then my question was, what did 7 and -4 have to do with this graph? Okay, I'm waiting for them to catch up though.
What do we put in there? X squared minus
6 minus 28.
That's where it goes, that's where,
So, if you notice here, Taylor was the first one here. You'll notice that you're crossing the x-axis at 7 and -4. Which, if you think about it, we're setting it equal to 0. So we're, do you have the x's in? So, alright. So, yes, 7 and -4 where you're crossing the x-axis. We said we wanted it equal to 0, which means we want our y-coordinate to be 0. Isn't the x-axis where y-coordinates are 0? You're not going up or down any. This one, if I wrote these as coordinates, my answer would be 7, 0. I'd be over 7, up 0. I have a y-coordinate of 0, and I have a y-coordinate over here. It says -4, 0, so my y-coordinate is 0. When you find the solutions of an equation, you're finding where it equals 0, and so you are finding those 2 points. Okay, was that weird?
no.
Okay, so, and actually the good news is, not only is this true on a quadratic with a parabola, This is true on every graph, every function you ever draw. If you're taking the ACT and they give you some horrible equation you don't know how to solve, if you go to your calculator and you find where it crosses the x-axis, you will find the real number answers. That won't find you imaginary answers, but that will find you the real number answers every time. Any graph ever, if you want to know where it equals 0, it's where it crosses the x-axis. So we're going to note that. And remember, okay, what were the names the other day for the solutions to an equation? They could be solutions, they could be roots. Answers, what's another name? It's an important name. Starts with a Z. The zeros. Solutions, roots, answers, zero. That's probably most of them. In all cases, your solutions are where it crosses the x-axis. Every single time. For us, though, if we want our calculator to find it for us, we have to. It can actually go do that for us, and we'll do it in a second. But I want to do something. I mean, that was an easy one to factor. You would never ever do that particular problem in your calculator because it's quicker to factor it than go to your calculator, go to the right page, all that stuff. But this dude I have here second, that's got horrible icky decimals. I don't think you want to try to factor that baby. But it is in a proper form that I can actually put it in my calculator. No, what do I need to do? Yeah. It has to be equal to 0. So we would have to move over the 1,271.12. Set it equal to 0. So you always have to have it equal to 0. Then we're going to go put that in our calculator. Okay. So I don't want to start a new graph page, so I'm going to hit Tab. I hope I'm going to hit Tab. Get out of the way. I'm going back up to that equation I just typed in, and I'm deleting it. So I can put in my negative 2x squared plus 107.7x minus 1,271.12. Oh, it didn't delete because I didn't hit enter. If you delete it and you press enter, it deletes. It'll delete in a second once I press enter here. Even after you pressed enter? Yeah, mine deleted and it put that one in. How come I can't see anything? Well, think about it. You put in 1,271. You really think that's going to fall between negative 10 and positive 10? Not. So, since I don't know where it is, it's out there somewhere. How am I going to find it? We are going to zoom out. You are right. So, menu, zoom, out. Ooh, okay, one click, I found one side of it that's 20 point something. There's 39.75, or I'm not that far. Just because I want you all to be able to see better, I'm going to click it one more time and move it over a little bit. Does it matter if I can see the vertex? No, because when you're solving, you just want to know where it crosses the x-axis. Who cares if you can see the vertex? You do not have to zoom out so you can see the vertex. That is unimportant. I want to find these two places where it crosses the x-axis. Given that this particular problem has some fairly icky decimals in it, there's probably a good chance my answer is going to have decimals in it. Okay. The good news is this works almost identically to how you found intersection points. Where you guess I go? Menu. Analyze graph. Which one? First one. Find zeros. Number 1, it's already highlighted for you. Okay, that's the exact same thing. Whoa, dude, where'd you go? Where'd my graph go? Oh, it's there. It's just really, really, really light. Hope you can see yours better. Wow. Okay, I'm going to get on the left side of that first intersection point, hit enter. You can only find them one at a time. You cannot do them both at the same time, sorry to say. So as I come across here, yep, it found a 0. It's telling me, hey dude, I got a 0. And so I would press enter, and it would tell me the coordinates of that 0 were what? So in my case, 17.4701, we're going to go 2 decimals, so 17.47 is good. Did you all get 0.47?
I said 0.5.
Yeah. I know how to fix it now. Who do I give credit for?
Me.
Who discovered it the other day? Andrew. Andrew gets credit for discovering how to fix this problem. Okay, we're going to fix this decimal issue on the graphs permanently. You're going to go to Menu, and at number 9, you're going to see Settings. Okay, well, whatever you're on. You go to Settings, Display Digits, it should say Plain Float. Yours probably says Float 3. Put it on Plain Float, and then go down and hit Make Default. Under Display Default Digits, you have to hit the arrow, and you'll get a choice for just plain old float. Did you find it? Okay. And then it should now forever give you more decimal places in your answer. Yay! I'm excited about this problem because it's been a problem. Okay, am I done with this problem? Yeah, 70.47 is one answer, but then you have to go repeat it again, go Menu, Analyze Graph, 0, get somewhere on the left of it. Holy mackerel, move my way out again. And then hit enter, and then move to the right of it, and hit enter. And this one turns out to be, okay, 36.3799, so what would I round to that? Round that to 36.38, yes. Okay, now, what's the deal with this other coordinate, this 1.165e, negative 10? What's that?
I didn't get that. I got 0.
Really close.
Yeah.
That's actually
It depends on how the calculator is processing the numbers, because that would be times 10 to the negative 10th power. That would be 0.00000000001. If it does that, it's the same thing as 0. Don't freak about that. That's just in the calculator handling in decimals. It would be 0. So we have 36.38 and 17.47. And you would have solved your problem. Now, y'all do realize that would solve every problem you do as long as it has real number answers. Can we ever not have real number answers? We can have imaginary answers, yes. Okay, so since I'm at the 13-minute mark, we're going to